Hi, in this video we'll be showing you how to complete hands-on 8, which focuses on the input data preparation for MAED EL. So having finished with the hands-on with respect to MAED D, we'll now be moving on to MAED EL. So by the end of this exercise, you're meant to be able to account for demand growth within your base year, calculate the seasonal coefficient for each week, calculate the daily coefficients for each day of each week, and calculate the hourly coefficient for each day of each season. Please make sure that you read the PDF carefully and you understand how the formulas work in order to be able to replicate this for your own country case if need be. In completing this exercise, we'll be using base year load data XLS, which is an Excel created to make this exercise simpler. You're welcome to use other software if you would like to. However, this is the one that will be used for the purposes of this exercise. So, firstly, to calculate the seasonal coefficients, it is necessary to know the electricity demand growth rate, which is given as R. This is between the base year and the preceding years. Once this is known, it is possible to calculate the trend deflator T for each week of the year using the equation below. More information on this can be found on the lecture slides of this hands-on. Now let us assume a 1% growth rate. What we're going to do in the load by week tab of the workbook, we're going to input this growth rate. So we're going to come over here and we're going to input 0.01. This is the workbook, and the one that we want to input is going to be the one that says growth rate over here for week 1. So we're going to put 0.01. Then what we need to do is calculate the TI, which is going to be, as stated previously, the growth trend deflator. Equation has been provided over here as to how that will be calculated. So all we need to do is just copy and paste this equation over here and then just spread it out for all the tabs. So the equation is as follows. It is equals bracket 1 plus $B $3 plus $B $3 close bracket to the power of, and then double bracket, A3 minus 26 close bracket divided by 52 close bracket. Once we've put this equation, all we need to do is just drag this down for the whole set in order for all of the numbers to get the deflator calculated. Cool, so once we've done this, we have the TI and the growth rate already inputted. The second step is to calculate the seasonal coefficients. To do so, the electricity demand for each EI should be divided by the corresponding growth trend deflator. Then we find the average weekly consumption. This is the sum of all the new values for weekly electricity demand, EI over TI, divided by 53, the total number of weeks in the study. Total number of weeks in the study. Next, we need to calculate the seasonal coefficients KI as the weekly electricity demand without the growth trend, EI over TI, divided by the average weekly consumption, AWC, and we should calculate 53 values. So over here it is EI over TI, hence we put equals divided by TI, and we get a corresponding number which matches with this. And then what we do is we spread this out for the whole period, which is 53. Ooh, one more. Next thing, as it was stated over here, we need to calculate the AWS. This is the sum of all the new values for weekly electricity demand divided by 53, the total number of weeks in the study. So what we're going to do is put equal, and then we're going to put the equal sum of all of these values close bracket, divided by 53, 308.142. Let's check to see if this is correct. Yep, this is correct. And then the last thing to calculate is the KI as the weekly electricity demand without the growth trend, divided by the average weekly consumption, AWS. So in this case, it's going to be equal to E3 divided by G $3. So equal to E3 divided by G $3. And then we do this for all the 53 weeks. So there we go. We can compare the results and we can see that the numbers are the same. Next thing to do is to calculate the daily coefficients. So what we need to go is go to load by week and day tab of the workbook. So if we come over here, we come over here. First, we need to calculate the average daily consumption in each week, PAVE as the sum of electricity consumption in the week given in EI divided by 7, which is the number of days in a week. So this is the one that we're interested in calculating, and as stated over here, it is the sum of the electricity consumption in that week given in the column EI divided by 7, the number of days in that week. So this number divided by 7, 37,957. Let's check to see if this is correct. That is in fact correct, and we need to do this for the whole period. So we extend this down until we get all of our figures. Then the daily coefficients are obtained by dividing the electricity consumption for each day by the average daily consumption for the corresponding week. So these are the ones that we're talking about. In order to calculate this again, we need to take the daily coefficients, which are obtained by dividing the electricity consumption for each day by the average daily consumption for the corresponding week. So equals this divided by this, and we can see that the number is correct. So what we're going to do is we're going to extend it for the whole period, and we're going to do the same over here, this divided by this, and we're going to extend it for the whole period, and then we do the same steps for all the days. I think I made a mistake over here. Yes, I had, so it was meant to be F3. There we go. Now we've calculated all these numbers, and they seem to be accurate in correspondence with this. The last part of this hands-on is to add the hourly coefficient data. So the hourly coefficients are calculated for each type of day, for example Monday, Tuesday, Wednesday, in each season for each sector or client, if that data is available. We're going to assume that we have identified the following 3 seasons using monthly consumption: January 1 to March 30, April 1 to October 31, November 1. Let us focus on Monday in season 3 during November and December. We assume that the hourly demand in the load by hour tab of the workbook is the demand of a hypothetical sector without any clients, so the whole sector is modeled as a single client. Firstly, we need to calculate the hourly coefficients for Mondays, for which we first find the average demand for each hour over season. We can do this using the table pivot feature in Excel in the load by hour tab to create a table with average demand for each of the 24 hours in every Monday and in November and December. So this is what we need to recreate. So if we come over here, I've recreated this already, but I'm going to show you how to do it again. In this instance, we select all of this. We go to insert, pivot table, from table range, press OK. And here we will have our table. Now, what we need to do is drag and drop the features that we need over here. So here we can see that in filters, we need monthly name and day name. So we're going to put the month name and we're going to put the day name over here. Here we're going to select in the month name, in this case, November and December. So we're going to press OK. And the day name, we're going to select Monday. We're going to press OK. Then coming back over here, we're going to see that in rows we need hours. So we're going to go over here and we're going to select the hours and drop it over here. And we're going to see that in values we need average of megawatt. So we're going to go over here, we're going to take megawatt, we're going to drop it over here. Now it displays the sum. We double click on it, click on average, press OK, and there we go. We have the numbers ready. The second step is that we need to calculate the average hourly demand as the sum of all electricity demand for each Monday divided by 24, the number of hours in day. This is already given in the grand total, so this is the value that we're looking for. To find the hourly coefficients for each hour, we divide the average demand for that hour by the average demand for all of those hours in that day, in that season, which is the grand total. So to do this, we're going to come over here, and as it is displayed over here, we're going to call it DI. So DI. And this is going to be done in the following way. We need to divide this B5 by, and we'll put the $sign to keep this value constant, which is B29, B$29, and then we drag the whole set of numbers, and there we go. We have our numbers ready. Going back to over here, we've completed each of the steps. So to calculate the input data for MAED, these steps would have to be repeated for each day of the week in every season for each client sector. So depending on what your data set is, how many sectors you have, how many clients, you would need to repeat this exact same steps in replicating your own personal country model. As mentioned over here, you need data on the hourly demand for at least each sector you wish to model in the base year and the reference year of all your study period. This is because typically the reference year have not happened yet. This data represents your scenario assumptions. So your reference year is when you manipulate this data to get your scenario assumptions. I hope that this video was useful to you. Thank you for watching.